Hi ladies and gentlemen, we are on our last set of notes for the unit, and we are going to take everything that we have learned about solving quadratic equations and we are going to apply them to some word problems. So if you take a look at question number 1, it says the length of a rectangle is 16 more than twice the width. Now remember, you always need to underline key information. So we're going to say the length of a rectangle is 16 more than twice the width. All right, and then it says that the area of the rectangle is 40 square inches, and we need to find the dimensions of the rectangle. So this is what we need to figure out. Only an algebraic solution is acceptable. So once we underlined our key information and figured out what we need to figure out, we need to ask ourselves, well, how many things do I not know in this problem? Well, I don't know the width and I don't know the length. So there are two things that I don't know. So I'm going to write two let statements, okay? So here's the thing, the length is based on the width. I can't figure out the length unless I know the width first. So we're going to say let the width equal W, which means that the length is what it says about the length. So the length of a rectangle is 16 more than twice the width. So to write twice the width, I would say 2W, but it's 16 more than that, so I'm going to say 2W plus 16, all right? So that is my two let statements. Then it says the area of the rectangle is 40 square inches. So remember, area is length times width. So I know the area is 40. So I'm going to plug that in for the area. And I know that the length is 2W plus 16. However, it's all of 2W plus 16, so I need parentheses around it. And then the width is just W. So what I need to do now is just solve my equation. Well, if I have a W on the outside, I got to distribute it through. So I end up getting 40 equals 2W squared plus 16W. All right? Now it's a quadratic equation because the exponent is to the second power. So that means that I have to get everything equal to 0 on one side if I'm going to try to solve by factoring. So I get 0 equals 2W squared plus 16W minus 40. And I always want to try it out by factoring first. So the first question I ask myself whenever I factor is there a GCF? And there is. The GCF is 2. So I'm going to factor out a 2, and then I've got W squared plus 8W minus 20 left over. By the way, once we get to this point, the rest is just review from what we learned previously this unit. So then I got to ask myself, is it a difference of perfect squares? And it's not, because it's a trinomial. That's what I have inside of there. So then I have to see if I can factor by trial and error or by grouping. I'm going to use trial and error. And I'm going to look for two numbers that multiply together to give me negative 20. So let's make a chart for 20. I've got 1 and 20, 2 and 10, 3 doesn't work, 4 works, 4 and 5. Now I'm getting to a point where I'm repeating, so I'm all set. And I'm going to try 2 and 10 because this is easy, this is quick. They're both W's because my A value is 1, so I can use 2 and 10, and that'll work out nicely for me to give me my 8W if the 2 is negative and the 10 is positive, okay? So now that I've done that, I can set each part equal to 0. So I say 2 equals 0, but I'm going to reject that because that doesn't make sense. 2 can never equal 0. I can say W minus 2 equals 0, which means W is 2. And then I can say W plus 10 equals 0, which means that W equals negative 10. Now I have two different answers, and we have to go back to the problem and think about what makes sense. So if the width is represented by W, can the width be 2 inches? Absolutely. Can the width be negative 10 inches? No, that does not make sense. So we are going to omit this answer because it doesn't make sense to have a negative length or a negative value for our width. So that means that W is equal to 2. So I'm going to go back into my let statements, and now I know that the width is 2. And what's the unit? Well, it says that the area is square inches, so the width is 2 inches. And then the length is 2 times 2 plus 16. So I get 4 plus 16, which is 20 inches. So that means that my dimensions are 2 inches by 20 inches. And that's my answer to question number 1. All right, ladies and gentlemen, let's remind ourselves about consecutive integers on the next page. So if my first integer was 5, the next integer would be 6, because all I'm doing is I'm adding 1 to go from 5 to 6. And then to go to the next one, I would add 1 again. So if my first integer is a, the next one is a plus 1, and the next one after that is a plus 1, which is a plus 2. I'm not going to spend that much time going over this because this is review and you guys seem to have a good grasp of consecutive integers. So if you have questions about this, please come see me and I'll help you out with it. All right, so if you have consecutive even integers, to go from one integer to the next, you have to add 2, and then to go from the next one to the third one, you have to add 2 again. So if the first one is b, the next one would be b plus 2, and then the next one would be b plus 2, so I would get b plus 4, okay? And then same thing with odd integers. If the first integer is 5, to go from 5 to 7, you add 2, and then to go from 5 to 9, you add 4, and then you would add even numbers every time. Remember, if it's odd, the common mistake that people make is they think they should do c and then c plus 1 and then c plus 3 because 1 and 3 are odd numbers. However, we add 2 and 4 because we have to skip the even number between our two odd numbers, okay? So let's take a look at question number 2. It says find 3 consecutive positive integers. So 3 consecutive positive integers such that the product of the second and third, and remember product means to multiply, added to the first equals 47. So let's take this little by little. If you break it up, it's super easy. So let's read it from the beginning again. Find 3 consecutive positive integers. Once it says that, my let statements need to be set up right away, and the let statements are easy. 3 consecutive positive integers. So I'm going to say let the first consecutive positive integer equal x. So then I'm going to say let the second consecutive positive integer equal. Now, a lot of people will see positive, and then for some reason it'll register in their brains that it's even or odd, but it's just positive. So it doesn't say even or odd, so it's just x plus 1. And then we're going to say let third consecutive positive integer equal x plus 2, such that the product, so I need to multiply the second and the third. So I'm going to multiply the second one, which is x plus 1, by the third one, which is x plus 2, added to the first, so I'm going to add the first, equals, so I'm going to say equals 47. So literally all I did was I read the problem and I broke it up into little pieces so I can translate it. Again, product, here's our multiplication of the second and the third, here's our second, here's our third, added to, here's our plus sign, the first, here's our x, equals, here's our equal sign, 47. Now all I have to do is solve it. So in order to solve this, what I need to do is distribute. So I'm going to distribute the x to the x and get x squared. Distribute the x to the 2 and get 2x. Distribute the 1 to the x and get 1x. And then distribute the 1 to the 2 and get 2. Copy the rest of it down, equals 47. Don't forget to copy down this plus x. When you combine your like terms, you end up getting x squared plus 4x plus 2 equals 47. Now, if this is equal to 47, we have our equation right here. However, this is to the second power, which means it's quadratic, so it's probably a better idea to not have it equal to 47 and to subtract 47 from both sides instead. That way we can get it equal to 0. So x squared plus 4x minus 45 equals 0. Then all I have to do is factor this, see if it's factorable. So I'm going to make a chart for 45. I could use 1 and 45. 2 doesn't work because it's not even. 3 does work because 4 plus 5 is 9, and 9 is divisible by 3, so 45 is divisible by 3. 45 divided by 3 is 15. 4 doesn't work. 5 works. 5 times 9 is 45. 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 works, but it's in my chart, so I've gotten all the possibilities. So I'm going to use 5 and 9 because I can get a 4 from those numbers because my A value is 1 and it's nice and easy. So I'm going to use a 9 here, a 5 here, make this positive, make this negative because 9x minus 5x combine to give you positive 4x. So now I can go ahead and solve. So when I solve, I'm going to set each part equal to 0. So I get x plus 9 equals 0, and then I get x minus 5 equals 0. Well, this means that x equals negative 9, and this means that x equals 5. So I have my two answers. But I have to go back into the problem and see, are there any restrictions on my answers? And there are. It says that they have to be positive, which means that I'm going to omit this answer of negative 9. It doesn't satisfy what we need according to the problem, which means that our only positive integer is 5, because that's what we got when we solved for x right here. We ended up getting x equals 5. So this is 5, this is 6, and this is 7. So my answers are 5, 6, and 7. All right, now that I've completed question number 2, I want to make sure my answer really makes sense. So it says that the product of the second and the third added to the first equals 47. So I'm going to take the second number, which is 6, and the third number, which is 7, and I'm going to multiply them because it says the product of the two numbers added to the first should be equal to 47. So right here, when you multiply 6 times 7, you get 42. 42 plus 5 gives you 47. So it works. I know that it's the correct answer. All right, question number 3. If the ratio of the width to the length of a rectangle is 3 to 5, and the area of the rectangle is 735, find the length and the width of the rectangle. So we know the ratio of the width to the length is 3 to 5, and that the area is 735. So I need to write my last statements. What two things do I not know? I don't know the width and I don't know the length. So we're going to say let width equal and let the length equal. Now, we know that they're in a ratio of 3 to 5, but we don't know how much this is going to be multiplied by. So it's 3 times some number to 5 times some number. So for example, if you had a ratio of 6 to 10, that reduces to 3 to 5 because it's 3 times 2 to 5 times 2, but this value has to be the same when you're reducing it. So if you don't know what the value is, we just call it x. So that means that our length is going to be 3x and our width is going to be 5x, all right? And then it says that the area is 735. And remember, area equals length times width. So I'm going to plug 735 in for the area. And the length is 5x and the width is 3x. So then when I multiply these guys together, I get 735 equals 15x squared. Now I can get everything all together on one side. However, because this is just a single x squared, sometimes it's easier to just get the x squared by itself. So what I'm going to do is I'm going to divide everything by 15. All right? And when you divide 735 by 15, you get 49. So 49 equals x squared. So when you square root both sides, you end up getting 7 as a positive or a negative is equal to x. So you can say that your answers are 7 or negative 7. However, same thing, there's no way you can have a width or a length be a multiple of negative 7. So what we're going to do is we're going to omit this answer. It does not work, okay? So that means that our width is 3 times 7, or 21 units, and our length is 5 times 7, or 35 units. So your answers are the width is 21 units, and the length is 35 units. Okay? All right, so I just want to check to make sure that this is the correct answer. So if the width is 21 and the length is 35, if I were to multiply them together, I could get my area, and it should be 735. So let's check to make sure that it works. So 21 times 35 does give you 735. And then I just want to make sure that it's really in a ratio of 3 to 5. So if my answers are 21 to 35, they're both divisible by 7, so you end up getting a ratio of 3 to 5, which does work for us. Okay? Let me know if you have any questions. I'll see you next class.